Okay, so in the last video, we looked at the idea of midpoint, and mid-segment. Okay, so what we're going to look at now is what's called the mid-segment theorem. Okay, and what this says is, let's say we have a triangle, A, B, C, and I'm going to label 2 points here. So, if EF is the mid-segment, then length of EF equals half the length of BC. So, to give an example, let's say we have a triangle A, B, C. Let's say we know that here's our triangle, and let's say we know that EF is 4. Okay, well, obviously E is a midpoint of AB, and F is the midpoint of AC. We can see that from the numbers because the length of AE is the same as the length of EB, and the length of AF is the same as the length of FC. So because of this, EF must be a mid-segment because it joins the two midpoints. Okay, so EF is the mid-segment. So what does that mean? It means that the length of EF is half the length of BC. Or it also means BC is twice the length of EF. So BC then must be 2 times 4 equals 8. Okay, so that would solve our problem. That would find BC. Okay, let's take another example. Okay, so again, E and F are midpoints. Looking at the numbers, EF must be a mid-segment. So BC is going to be 2 times the length of EF. Because EF is a mid-segment, so it's going to be 2 times 3, which is going to be 6. So BC is going to be 6. Okay, let's take one more example. Okay, and the question here is what is the length of EF? Okay, well obviously EF, they are midpoints. So that means, let me label the A, B, C here. So E and F are midpoints, so that means BC is going to be 2 times the length of EF. BC is 8, so 8 is going to be 2 times EF, length of EF. So that means the length of EF must be 4, 8 divided by 2. Okay, so that is some theory and practice with finding distances using midpoints.